Well, Algebra Geometry 3 classes, good morning. We are going to go ahead and post a video over the 7.3 notes. I know some of you were gone yesterday. This way, if you were, you can complete the notes for this section at home, and then we will also repost a copy of the worksheet here shortly for you. But just to kind of recap from what we went over yesterday, the 7.3 solving systems by elimination notes. When you're working with elimination as opposed to graphing, we're going to algebraically find the solutions, and in doing so, we always are looking to what can we do to get rid of one of the variables. You solve for it, then you plug that value back into one of the equations, and you get the other variable, and then you have an ordered pair for where they cross for things that wouldn't be easy to graph. So now, example 1 and 2 are probably two of the easier ones where when you look at it, I've got a negative 2y and a positive 2y. You can just go ahead and add those two equations as is. So you get 11x, the 2y's cancel, 4 plus 18 is 22, and then you divide the 11, and x is 2. Now, as we said, normally I know you get your solution, you're done. We are only half finished at this point. What we now do is we take this variable and you plug it back into one of the original two equations. It doesn't matter which one you use. I know for this one, I kind of like using the bottom equation because all of my numbers are positive. 6 times 2 plus 2y equals 18. 6 times 2 is 12. And then, kind of like before, you just solve for y. Minus the 12, and then your last step is to divide the 2, and y is 3. So the ordered pair where they cross, if we would have graphed, is 2, 3. Now, as we move over and look at question number 2, again, the nice thing about this one, I have a positive 3 and a negative 3, so I can go ahead and add those as is. They cancel. Negative 5y plus 6y is just y. So this one actually is even nicer because you don't even have a coefficient with y. 13 plus negative 15 is negative 2. So there's our first variable. Now we plug this back into one of the equations. Again, it's kind of your choice here if you want to use the top one. I know over here we use the bottom one. It's kind of your decision now. I'd say it's probably about even either way. I'll use the top one here. 3x minus 5 times y is negative 2 equals 13. Then we have 3x negative 5 times negative 2. That's where you do have to be careful, is 10. Then you subtract 10 and 3x equals 3, and so just kind of out of room here, divide the 3, and x is 1. So again, just rewrite it as an ordered pair. It's 1, negative 2. So those are the first couple where you have a variable that will cancel automatically by just adding. Now, you have to be careful with examples like 3 and 4, where here when both x's are positive, if we were to add these as is, nothing cancels. So we have to multiply one of them by a negative 1. Again, it's kind of up to you. I'm choosing the top row for a reason that I think is kind of useful, because now when I do negative 1 times 3, negative 3x. Negative 1 times y is positive y. Negative 1 times 3 is negative 3. Now I can use my bottom row and add. So now the 3x and negative 3 cancel. 9 and y is 10y. 33 and negative 3 is 30. Divide the 10 and y equals 3. Now, for this one, again, when you plug back in, always use one of the original rows. Yes, you can, in theory, use one of the ones that you multiplied by. I don't recommend it because if you happen to make an error, then, you will get the wrong second variable. So I'm just going to plug directly into the top row since it only has y. So 3x minus 3 equals 3. Now we add the 3, and 3x equals 6. Divide, and x is 2. So I know it's kind of randomly interesting that both 1 and 3 happen to have the exact same answers. Now, as we move over to number 4, you have the same issue. Negative 5y and negative 5y. If we add these as is, they won't cancel. You end up with negative 10. So what we have to do is multiply by a negative 1. And because I know I'm kind of crowded here, wanting to use a different color there. So it gives us negative 20x, again, because these two negatives won't cancel without a sign change. Plus 5y, negative 45. Now we can add our new row with the bottom row. That's negative 17x. The y's cancel. 11 and negative 45 is negative 34. Divide by negative 17, and x is 2. From here, plug it back into one of the original rows. Now I'm going to use the bottom row. I look at this, these have larger numbers. So when I do 3 times 2 minus 5y equals 11. That's 6 minus 5y equals 11. Subtract your 6. Negative 5y equals 5. And then you divide. So y is negative 1. So the solution, where, again, not that we are graphing any of these, they would have crossed at the point 2, negative 1. All right, final 2 questions. We have something else show up that is now a little different here, in that none of our coefficients are the same. We have 1 and 3, negative 2 and 1. So not only are we going to need to multiply by something like a negative, we are going to even need to use another number. So when you look at this, we have a 1 and a 3, we have a negative 2 and a 1. Depending on what you choose, you can eliminate either x or y. That's up to you. If you see here, there's a positive 3. Well, to cancel with a positive 3, I need a negative 3. So what I can do now is not just distribute with a negative 1, but distribute with a negative 3. Negative 3x, positive 6y, positive 24, and then I can add these. The x's cancel. Y and 6y is 7y, 4 and 24 is 28. Divide the 7, y is 4, and then we just plug it back in. Again, if you see one like the bottom row here where all you have is a y, probably your easier option, 3x plus 4 equals 4. Now, solve for x. Subtract the 4, 3x equals 0, divide, and x is 0. So the point where, again, if we would have graphed 0, 4. One final question, which will sometimes occur, is question 6, 5 and 4, 3 and negative 5. Now, this one's a little different as well, in that, unlike over here, I could just multiply by a 3, and now the coefficients or the numbers in front match. That's not going to be an option for this one. We are going to have to multiply both rows. Now, one thing that it's kind of up to you, if you see this, where I have a 3y and a negative 5y, I am going to multiply both of these and come up with 15. So what I'm going to do, I'm going to use 5 for the top row, 3 for the bottom row. And so when I do that, 25x, 15y, and 60. Then when I distribute to the bottom row, 12x, minus 15y and 51. Now, you could have done the same thing with the x's using 4 and 5. You'd want to make one of those negative. Because I've already got a built-in positive and negative, I'm using y. And so now you add these up. The y's cancel. 25 and 12 is 37x. 60 and 51 is 111. And then you divide by 37, and x, when you do that, is 3. Final thing I now have to do is plug it back into one of these. Here I'll probably actually use the top row. Everything's positive, maybe a little bit easier in that regard. I know also, as you can see, the work does start getting a little cluttered on these ones where there's a little more to them. 5 times 3 is 15. Subtract that over, and when you divide, get y is negative 1. So the point where they cross is 3, negative 1. So kind of a quick wrap-up video. Again, if you were gone yesterday, if you want something to go back, kind of watch through as you are working on that worksheet, which again we gave you yesterday in class. We will also repost a copy. If you can't print, that's fine. You can just even write the workout on your own paper, but most of you do have a copy of that worksheet. So we may see you tomorrow. We'll see what happens with the weather.